Well, hello, and welcome back to the Algebra 2 jungle. And tonight we're going to tackle phase shifts, which is just another fancy name for horizontal shifts. And we've tried to shift a lot of different types of functions, either to the left or to the right this year. And tonight we're just going to take those same concepts and try to apply it to our sine and cosine functions, which together make up a family called sinusoidal functions. And so what we've got is we brought in a couple of our best friends here to try to show us this pushing or pulling action. And my first little buddy here he's trying to push the red graph on top of the blue graph so that they coincide. Or down here, these two little rascals, they're trying to pull that blue graph back onto the red graph. So either way, we're going to be doing a lot of pushing or pulling tonight. We're going to slide them left, slide them right, and also try to review everything else that we've learned as far as amplitude, frequency, period, and vertical shifts. So as we said in the last slide, that a phase shift is simply a horizontal shift. Nothing fancier than that. They just tend to use the word phase, and they reserve that for dealing with trig functions only. And so for instance, if they gave me this function sine of x and they wanted me to create f of x minus 2, again, it's a simple act of substituting the quantity x minus 2 in for the original x. And what we're going to do here is we're pushing the graph to the right 2 units. Another example they might try to throw at us is x plus pi. And a lot of our shifts today are going to be in terms of pi. They don't have to be, but a lot of them are. Again, I'm going to just take the quantity x plus pi and substitute it in for the original x. Or another way to say that is we're replacing the original x with the quantity x plus pi. And what that's going to do is that's going to shift everything to the left pi units. Let's see, what else could we try? We could maybe try to do f of x minus pi over 4. And then it would look like the sine of x minus pi over 4. Big key here is that the minus pi over 4 is inside the parentheses, something we've tried to stress with all of our horizontal shifts. And now we're going to shift the sine curve to the right, pi over 4 units. Let's see, what if we wanted to do, again, we said a lot of them are going to be in terms of pi, but they don't have to be. We could say f of the quantity x plus 4, which now becomes the sine of x plus 4. And we would be shifting everything to the left 4 units. Now before we go any further, eventually we're going to build on top of these horizontal shifts and start to incorporate all the other characteristics of a sine and cosine curve. We want to just do a quick recap of the general form of any sinusoidal curve. And basically when we say sinusoidal, we're saying this could be a sine or a cosine function. It really doesn't matter. So we'll start with the leading coefficient of a. We know that the absolute value of a represents the curve's amplitude, which is just simply the distance between the midline and the max. Let's see, this next coefficient, b, represents the curve's frequency. And then from the frequency, we could then create the period. So we know that 2 pi divided by the letter b is going to be the curve's period. In other words, that represents the number of radians it takes to complete one cycle. Then this letter C represents the phase shift. And it'll dictate whether we're going left or right. And then the last number there dangling at the end, the letter D, that's going to be our vertical shift. And that's going to dictate whether we need to go up or down at all. So that's just a real quick recap of the general form. Now one of the things you notice on that last slide is we had what we call a double set of parentheses. And here's the key today. The trickiest part of today is making sure that the coefficient of x is a 1. And that has to happen before we can identify the phase shift. See, right now, if we jump the gun, we'd say that the phase shift is 6 units to the right, but that is incorrect because the coefficient of x is a 2 right now. And until we force that coefficient to be a 1, we're unable to identify the phase shift. So what I'm going to do is I'm going to kind of factor out a 2 while maintaining or creating a double set of parentheses. And here's what it would look like. Alright, so I'm going to factor a 2 out, and if I divide the first term by 2, I get an x, and if I divide the second term by 2, I get a minus 3. Notice, again, the double set of parentheses. Now we would say that this x has a coefficient of 1, and we can identify the phase shift, and we would say we're simply moving to the right 3 units. Let's take a look at another one, maybe a little more complicated. Let's say we had the sine of 3x minus pi. Okay? Again, if we jump the gun, we'd say, well, we're going to the right pi units, but that's incorrect because we still have a coefficient of 3 and we want to force this coefficient to be a 1. So here's what we got cooking. We're going to factor out the 3. And when I divide the first term by 3, I get just x. And when I divide the second term by 3, I get minus pi over 3. So now we're shifting this curve to the right, pi over 3 units, or 60 degrees, however you want to say it. I'll try to come up with one that's even a little bit crazier. And again, and I'm going to stress, we could use sine or cosine. It really doesn't matter. Let's say I had 4x plus, we'll do a plus 1, pi over 2. So this one's a little bit goofier. And let's see, we want to factor out the 4. And the first term divided by 4 equals x. And the second term divided by 4 ends up being pi over 8. And so we now say we're going to the left, pi over 8 units. So we're gradually building throughout the video, trying to incorporate everything that we know about sine and cosine curves. So the question now is, can we simultaneously combine a vertical and a horizontal shift? Whoops, move that bear over there. Okay, so the first one, let's use the cosine function as our parent function here, and we're going to see if we could create f of the quantity x plus 2, and then we've got the plus 3 outside. So what I'm going to do is I'm going to replace this x with the quantity x plus 2, and it now looks like the cosine of the quantity x plus 2 plus 3. And what we've got cooking here is, so here's your phase shift and here's your vertical shift. So we're going to go to the left 2, and then we're going to go up 3 units. Another similar one is f of the quantity x minus pi with the minus 4 on the outside. So we're inside here, outside here. Let's see if we can build that function. Cosine of the quantity x minus pi minus 4. And what we're moving to the right pi units, and then we're going down 4 units. Whoa, this is a pretty intimidating looking equation right here. It's got a little of everything, so we really got to shake and bake. And our challenge is, can we put it all together, everything that we've learned over the last 3 nights. And the best news is what's happening right in here. You'll notice that we do have the double set of parentheses. In other words, we'd say that this quantity in here is factored and this x has a coefficient of 1, which is great news. Okay, so we'll go step by step. Part A, the amplitude is going to be the absolute value of negative 4, which ends up being a 4. Let's see, the frequency, again, is going to be this coefficient right here. So we could say the frequency is a 2. And then I'm going to use my little formula to find the period. We'll say the period is going to be 2 pi divided by that frequency, which turns out to be 2 pi divided by 2. 2's cancel and we get a period of pi. So we'll see one cycle right at pi, assuming that we're starting at 0, of course. The next part, D, is my phase shift. We're going to go to the right, pi over 4. And the vertical shift is going to go up 13. So that's a lot of things to incorporate all at once, but hopefully by identifying all of these characteristics, we could then eventually be able to put them all together and create a great graph. Similar to the last question, we want to try to identify the amplitude, the frequency, the period, and then the phase shift and the vertical shift. So we're looking for 5 things. And there's, boy, the bad news here is that this quantity is not factored yet. We don't have the double set of parentheses, or in other words, the coefficient of x is a 4, and we want to force this coefficient to become a 1. And so what I'm going to try to do is just try to factor it real quickly here. And if I factor out the 4, what I'll do is the first term turns into an x, and the second term turns into pi over 4. Now again, if you're ever doubting that, what you can do is you can take this 4, distribute it back to both those terms, and ensure that it equals the original 4x plus pi. So let's see here. The amplitude is going to be the absolute value of 5. The frequency is going to be 4, so we'll see 4 cycles at 2 pi. The period is going to be 2 pi divided by 4, which reduces down to pi over 2. So we'll see the first cycle, whoops, that's a 2. 2, 2, 2, 2, 2. We'll see the first cycle right at pi over 2. My phase shift is going to be to the left, pi over 4 units. And then my vertical shift is going to be down 7 units. A little crazier. Now we're going to try to do the reverse or the opposite of what we just did. We're going to try to create that equation ourselves based off of the following characteristics that we've got cooking here. The first thing that I like to do is I just like to write down the general form of a sine curve. So it would be the sine of, we said b multiplied by the quantity x minus c, and then plus d at the end. And we defined who a, b, c, and d were earlier. Let's see. So if I plug in all the appropriate information, I'll substitute the 2 for a. Let's see. The frequency is a 3. My phase shift, now we're going to the right, so I'm going to keep this as a minus pi over 3. That's going to push it to the right. And then we're going down 6, so I need to subtract 6. And that's exactly what my equation would look like. Very similar question to the last one, except for one minor hiccup. Notice the second line right here. They're giving me the period instead of the frequency. Now our life was a lot easier when they gave me the frequency, because the frequency just goes right in for B and we're done. Now the trick is, can we use the period to find frequency? Alright. Now what you'll recall is that the formula for period is P equals 2 pi divided by F. And in this particular case, we know what P is. We know that that's got to be 2 pi over 3. And the question is, can we now solve for F? If I cross multiply, I'll get 2 pi multiplied by F equals 6 pi. And then we're going to divide both sides by 2 pi. You'll notice that the pi's cancel right away, and we get F equals whatever 6 divided by 2 is. So now I've got my frequency, and I think we're in a great position where we could put it all together. And we'll say y equals negative 3. Now actually, shucks, technically I guess we should say that was a positive 3, because the amplitude could never be negative. And when we write the equation, you're not really sure whether it should be negative or positive, so we'll just, by default, we'll go positive, but don't lose any sleep over that. Alright, the frequency is a 3. I'm going to do x plus pi over 4 because we want to move to the left. And then at the end, I'll put a little plus 12 for the vertical shift. I'm going to ask you to do a few different things here with this picture that I've given you. And then the first thing I want you to do is I just want you to try to write an equation for this curve by looking at it and analyzing its amplitude and frequency and period and all those things. And the good news is this is a very well-behaved function. First of all, do you feel like it's a sine curve, or do you feel like it's a cosine curve? And the trick here is you'll notice it starts with a max. Now, when I talk about where the graph starts, I'm analyzing where x equals 0. And if it would have started at the origin, I'd say sine curve. But if it starts with either a max or if it starts with a min, now I'm calling it a cosine curve. And it happens to have, looks like an amplitude of 3. So I'm going to go 3 cosine. The good news is the frequency is 1, because starting at 0, we just see one cycle at 2 pi. And there's no upward shift, there's no left or right shifts, nothing like that. So that's just simply 3 cosine x, very simple, well-behaved function. Now my challenge to you is, on the same axes, can we graph 3 cosine of the quantity x minus pi over 4? Okay? And what you'll notice right away is we're trying to shift the graph. We're trying to move to the right pi over 4 units. So I'm going to try to do that, apply that to each and every point here on the graph. And let's see what this is going to eventually look like. So for instance, there's a relative max right here at x equals 0. I'm going to slide it to the right, so it's boop, right there at pi over 4. And then it looks like there's a 0 at pi over 2, and I'm going to slide him to the right, so it's 3 pi over 4. There's a relative min at pi. I'm going to slide him to the right, and now it's at 5 pi over 4. The 0 that we have at 3 pi over 2 is going to move over to 7 pi over 4, and etc. So the graph is going to start to look like this, and then I'll kind of mosey on there. Working backwards, this 0 at negative pi over 2 is going to slide over to negative pi over 4. This relative min at negative pi is going to slide over to negative 3 pi over 4. The 0 at negative 3 pi over 2 is going to slide to the right and hit negative 5 pi over 4. And this other relative max is going to end up at negative 7 pi over 4. So the graph is going to start to move like this. If you can picture one of those minions pushing the green graph over to the blue graph. Same idea here. We want to try to write the equation of this purple graph. And the one thing I want to stress here is identifying the midline. This is really going to help you, especially when it's a sine curve. And what you'll notice is that the relative maximums have a height of 7 and the relative mins have a height of 3. And the average of 7 and 3 is at 5. So you can imagine the midline being right here at y equals 5. And then what you'll notice is that convinces us that we're working with a sine curve, because right here when x equals 0, the curve starts right on the line y equals 5, or right on our midline. Ironically, it's upside down, so it's swooping down before it goes up, so we got a negative coefficient here. And I'm going to go with -2 sine of x, and it looks like because of where the midline is, we have a vertical shift of up 5. Again, why did I throw a negative in front of the 2? Well, that's simply because the graph went down before it went up. Alright, I think we're ready to try something new. Can you draw this equation? Can we do sine of, let's say, pi plus pi over 6 plus 5? So I want to take the curve we already have and we want to go to the left, pi over 6. We'll make sure we've got that documented, left pi over 6. Now remember, pi over 6 is about 30 degrees, so that's a very short jump that we're going to take. And for instance, if I start right here with this relative min and I want to go left pi over 6, we're going to estimate that that's about 1 or 1.5 blocks, and so it's a very subtle shift. And what I'm going to do is I'm just going to apply that to every point on the graph. So I'm moving about 1.5 blocks to the left. It's not an exact science because of how the scaling was presented to us. So again, I don't want you to lose any sleep over that. But hopefully we understand that we're not moving to the left a lot, just a very subtle movement to the left. Oops. Let's see here. Try to be as smooth and cyclical as I can be. And that's what it would look like to go left pi over 6. Real quick recap of how to distinguish between whether it's a sine curve or a cosine curve. Again, when we talk about where the curve begins, and this is a word we use quite often, when we talk about beginning, we're analyzing the point where x equals 0. And the sine curve is always going to start right on the midline. If there's no vertical shift, then that would just be at y equals 0, right on the x-axis. Whereas the cosine curve is going to start either at its max or it could start at its min. But it won't be on the midline, that's for sure. Boy, this next problem is a very challenging one, and but we're going to have fun trying to tackle it. And I'm going to introduce some new lingo. I'm going to call one of these curves the primary curve, or in other words, the original. Okay, and that would be before any phase shift was created. And then I'm going to introduce you to a term called the secondary curve, which would be the new curve after the phase shift was impacted it. So below, and I'm going to kind of give you a hint here, we're working with a sine curve, it says. And it's a sine curve because what you'll notice right here is that the purple curve begins right on its midline. Alright? And again, just to recap, when we say begins, we're referring to x equals 0. And it begins right on the line y equals -3, which is the midline. Now I want you to write an equation for the primary curve, which would be the purple one in this particular case. And then we're going to write an equation for the secondary curve, which would be the orange curve. Again, primary is before the phase shift, or we could say no phase shift. And the secondary curve is with the phase shift applied. So as far as the purple curve goes, it looks like from that midline, it looks like we're going to go up 2 units. So I'm going to go 2 sine. And let's see, I'm only seeing one cycle at 2 pi. So we're going to go x, close the parenthesis, and then we'll say -2 because of where the midline is. Now the orange guy, did we shift him to the left or to the right? Interestingly enough, there's more than one right answer. And that's what makes some of these problems so much fun, is because it's all in the eye of the beholder. Do you visualize the orange graph as a shift to the right or a shift to the left of the purple graph. But what I'm going to do here is I'm going to focus on a shift to the right. So I'm going to pretend that I'm going this direction right there. And it looks like the original point that started on the y-axis went to the right. It's kind of tough to see on this one, but you'll notice it's more than pi over 4, but it's less than pi over 2. So again, we're focusing on this distance right in there. Now, again, if we are to assume that it's a friendly amount, it's a radian that we're very familiar with. Can you think of a radian that's bigger than pi over 4 but smaller than pi over 2? And the one that comes to mind is the radians for 60 degrees, which would be pi over 3. So everything else about this equation is going to stay the same. I'm just going to go to the right, pi over 3 minus 2. And again, we'll talk about that in class, but we can assume that this is going to be a very friendly number, and probably based on the scaling here, it would be, it'll be very easy for us to tell. So my first job, similar to the last question, is try to determine who's the primary curve. Is it the black curve or is it the red curve? Which one's primary? And so what we'll try to do is, it's all about where we're starting, and I'm going to say right off the bat, I'm going to tell you right up front that we're working with a cosine curve. And I'm going to say it's a cosine curve because when x equals 0, this black curve starts with a min. So if it's a min or a max that it starts at, then it's a cosine curve. So again, we want to write an equation for the primary curve, which involves no phase shift. And then we'll write an equation for the secondary curve, which in this case, we'll say the secondary was red, primary was black. And the secondary curve is the one that has a phase shift in it. So we got to decide whether it goes left or right and how much. Okay, so beginning with the black curve here. Again, we said we know it's a cosine curve. Now it looks like the minimum height's at -1, and it looks like the maximum height is at 7. So the average of -1 and 7 would be at 3. Can you picture the midline right here at 3? Kind of splitting the curve in half. Okay. And the distance between the midline and the min looks like it's 4 units. So I'm going to say -4 cosine. Let's see. We know there's no phase shift. Now, what was the frequency? And maybe I should leave myself a little more room right there. Looks like if I count the number of cycles, the black curve completes 2 cycles at 2 pi. So I'll say got a frequency of 2, and then we said we went up 3 units. Why was this 4 negative? Well, because the curve started with a min as opposed to a max. Now let's see if we can do the red curve. It's going to be exactly the same. We just have to decide how far left or how far right we're going to move. Got the double set of parentheses in there. Unfortunately, this one's much, much friendlier than the last one, which you notice, let's say we took this point right here and we went to the left, pi over 4. So I would do plus pi over 4. Much, much friendlier. It's easier to see the pi over 4 than it was the pi over 3 from the last one. So, but that's how it goes. We'll give it our best shot. I think about 80% of the sheet tomorrow is going to be really, really easy and super, super quick, and that'll give us time to focus on these last couple of rascals that are more challenging. So have a great night. We'll see you tomorrow.